How do we extract aluminium from its ore, bauxite? Let's go into it. Roll that graphic. Hi, I'm Paul. Welcome back to Science That Sticks. Today I'm going through how to extract aluminium from its ore, bauxite. How do we do that? Well, first of all, you need a nice red rock that's called bauxite. It's really easily spelled Bauxite and contains aluminium oxide, Al2O3, aluminium oxide. Now, turns out that we can actually dig this out of the ground. What makes it worth doing is the fact that there's a great deal of this aluminium oxide within the rock. So a few chemical reactions are taking place so that we can get the aluminium oxide on its own. We call this alumina. It basically contains this. Now, unlike iron and copper, aluminium is above carbon in the reactivity series. Because it is above carbon in the reactivity series, we can't use carbon to displace the oxygen from aluminium. So how do we do it? Well, one way of doing it would be to use magnesium, which we could use in the thermite reaction, but more commonly, and because we're going to manufacture it and we don't want the reaction to get out of control, is we have to heat it up. We have to electrolyze it. So let's walk through that. Now, once you've got the aluminium oxide, you need to get it into a molten state. So not as a solid, but it needs to be as a liquid. Now, once it's a liquid, it can be electrolyzed. Now, I'm going to do a very different diagram to that which you will see in examinations. Normally, the reaction vessel for aluminium oxide is a rectangular thing. I'm just going to do it here in like this giant sort of pit kind of affair. Now, what I'm going to do is I'm going to say that this right here is the positive electrode and this here is the negative electrode. In the molten aluminium oxide, now we've also got to discuss something that I've not yet talked about, and that's cryolite. Melting this, because it's an ionic compound, is very, very difficult to do. In fact, it costs quite a lot of money and takes quite a lot of heat to get this to melt down. So you add something called cryolite to reduce the melting point. Once you've got it molten, you can then put a current through this. Now, of course, the aluminium ions are Al3+, and the oxide ions that are present are O2-. The moment they are molten means that they are mobile charge carriers. In other words, they're free to move and they will conduct electricity. They will go to the oppositely charged electrodes. So aluminium will go to the negative and the oxide ion will go to the positive. The O2- ions are anions. Note, so I've done the anion, the an part is a minus, and the cation, which happens to be the aluminium, I've replaced the T with a plus so that you can remember which one's which. Now, this cation will be attracted to this electrode. We call this the cathode. The cathode attracts cations, but remember, it is negatively charged. Now, once it's at the cathode, something takes place. In other words, something happens to this ion, and what happens is that it gains 3 electrons. So we have this Al3+, it gains 3 electrons, and we make aluminium. Nice. We call this a half reaction or a half equation. It's not half the reaction, it's just a half equation. Just showing what happens to the electrons. Over here at the anode, we have O2- ions. Now we need 2 of those because what we get is oxygen gas, which is O2, and we get 2 lots of electrons. Now, reduction is the gain of electrons. So here, this happens to be reduction. The oxygen happens to get oxidized because oxidation is the loss of electrons. And that's pretty much it. The key facts, as we go through this one more time, are you need bauxite, which is the ore for aluminium oxide. You need to melt it down because you can't put carbon in it to react it with carbon as a displacement reaction. There's one other thing that I've not mentioned, and that happens to be what the anode is made of. The anode is made of graphite. Graphite is carbon, and carbon will react with those 2 oxygen atoms, and we end up making carbon dioxide. And because carbon dioxide is a gas and because this mixture is at 995 degrees Celsius, it's pretty warm, that carbon dioxide escapes into the atmosphere. And so this wears away and it needs replacing. That's everything. That's all there is about the extraction of aluminium. Learn it. Make sure that you're able to answer good questions. Use a variety of sources. Use your own judgment. Use your imagination. But actually remember these things. Until next time, take care, everyone. Stay cool. Bye-bye.